Hello guys, welcome back. So today I will be discussing the sort of to me I when I was discussing this problem in class. This was I felt that this was the hardest problem in statistical inference for IIT JAM 2020. So I thought I should dedicate some time specifically for it. Okay, and this is really so if you are looking for some strategy for statistics, I mean it should be related to stuff like just applying the problem like the theorems, okay, blatantly. So the in that sense, so but this required some so this required so this you must understand that when to apply theorem. So that's why I made this video to make you comfortable with that. So if you see the problem asks that there is a data, okay, which is just for computing the number in numerical form. Essentially the problem is all about there is some Poisson theta distribution sample, and you have to find out the mean like the parameter. It's given a parameter like this, and you have to find the minimum variance umve on parameters like umve of this parameter psi of theta. So if you remember the algorithms to find umve, the most important algorithm is Lehmann-Scheffel. Okay, so it's the most important algorithm, and whenever you are given very weird parameters to estimate find the umve, then also it's like laymanship. For example, I will give you the example. For example, this one take it's 58. It's not an easy parameter to understand, right? You can also use laymanship here. Okay, so same type. So essentially it's not a normal parameter, it's a function of the normal parameter, and then that's why when you use laymanship, so the first step is that you have to find an unbiased estimator, okay, of that. And observe the unbiased estimator of that is probability indicator x1 is greater than 3. Okay, I mean this is means what, this is like sum of all the probabilities from 4 to infinity. So if you take the indicator random variable, uska expectation is the probability of that event, right? So you take the event that indicator event that x is greater than equal to 4. Okay, that means x is greater than equal to 3. So therefore if you want to take expression of t, you get probability x1 greater than equal to 4, which gives rise to the psi of theta. So therefore this t is the first step, the unbiased estimator step. Okay, this class was taken in our problem solving class when we were discussing 2020 problems, and that in that class there were some problems to understand how this was done. So that's why I'm like again discussing this. So this is a t. Okay, now what does Lehmann-Scheffel tell us? Lehmann-Scheffel tells us that now if you got a t, okay, now you have to condition that t the based on the complete and sufficient statistic of theta. Okay, and therefore what you get is that you have to find the complete and sufficient statistic of theta. I mean based on sufficient statistic, a complete and sufficient statistic. If you just condition on that, then you get another what, another like better you get the umve. Okay, that's what Lehmann-Scheffel tells us. So therefore what is the complete and sufficient statistic of theta? It's x bar, right? That is x1 plus x2, x1 plus x2 here. Okay, x bar, it's a like one-to-one function. So essentially x1 plus x2 is a complete and sufficient statistic of theta. Now if you condition t on that, you get psi dash of theta. So that's the idea. If you condition t on that, you get the psi dash of theta. Here it's written. This is the idea. And if you condition on that, since x1 plus x2 is complete and sufficient. Okay, this is also important. Now you have to find it out. Now essentially it's what? If you just take the, it's indicator x1 greater than 3. So essentially it's probability x1 greater than 3 given x1 plus x2. That's what you have to find out here. Okay, if you find it out now, what will happen? Now there is a result. The result that x1 given x1 plus x2 follows binomial. So if x1 x2 are points for theta, in fact it's points for lambda 1 lambda 2 and it's lambda 1, so it follows binomial. Okay, what is this s? Do you know what is this s? It follows binomial x1 plus x2, comma lambda 1 by lambda 1 plus lambda 2. Two events are occurring with lambda 1 and lambda 2 proportions in some sense. Frequency and probability of the x1 given lambda 1 plus lambda 2 sort of follows with proportion with probability, like follows a binomial random variable with x1 plus x2 given trials with probability lambda 1 by lambda 1 plus lambda 2. If you just, since here lambda 1 and lambda 2 are theta, so it follows that it follows binomial x1 plus x2 comma half, where x1 plus x3 is 5. You observe it, x1 plus x2 is 5. So therefore you get that it follows binomial 5 comma half. Okay, now you can easily find the probability x1 greater than 3, that is 1 minus probability equal to 0, b is equal to 0, b is equal to 1, b is equal to 2. If you just set it up, you get this, which is equal to 13 by 16. So this is the idea behind this problem. Okay, so when any good problem is always based upon a good theorem, uska application and some probability. Okay, probability is a like the basic building block of the entire thing. So if you're very good in probability, I'm sure no one can beat you in this statistical journey. Okay, so all the best and see you in the next problem video. Until then, have a very good day. See you in the next video. Stay tuned and stay blessed.